This video is about Pearson's product moment coloration coefficient. Don took part in a project investigating wind speed x km/h and the time y minutes to fully charge a solar-powered robot. 1H. Calculate R. Pearson's product moment coloration coefficient between the wind speed and the time to fully charge the robot. We will use a graphing calculator to figure out the Pearson's coloration coefficient. Go to Stat, Edit, put x wind speed into L1, the time into L2. You need to press Mode, make Stat Diagnostic on. Move the cursor to Stat Diagnostics. Default is off. You need to make it on. Then second mode, quit. Go back to Stat, Calculate. Press 4, Linear Regression Line. Then L1, L2. No frequency list. You can store your regression line into L1. Alpha trace. Enter. Or you can choose not to do this step. Then calculate. You are given the equation of a regression line. A is the slope. B is the intercept. Also, these are Pearson's coloration coefficient, 0.944. Let's talk about Pearson's product moment coloration coefficient. Pearson's coloration coefficient R indicates the degree and direction of a linear relationship between two variables. So when you describe the Pearson's coloration coefficient, you have to say its strength and direction. This is the formula for Pearson's coloration coefficient. The value for R is between -1 and 1. When R is positive, we see there is a positive coloration between two variables. If R is negative, we see there is a negative coloration between two variables. When R is between 0.75 and 1, or R is between -1, -0.75, we see there is a strong coloration. If R is around 0.5 or -0.5, we see the coloration is moderate. When R is around 0, we see the coloration is very weak or no coloration. So for 1I, describe the coloration between the wind speed and the time to fully charge the robot. You have to see its strength and direction of a linear relationship between these two variables, which is a strong and positive coloration between the wind speed and the time to fully charge the robot. Let's draw a conclusion about Pearson's coloration coefficient. It indicates the degree and the direction of a linear relationship between two variables, and it will be affected by outlier a lot. So, in order to get accurate Pearson's correlation coefficient, you need to figure out the outliers for both variables. The square of Pearson's correlation coefficient is called the coefficient of determination. R squared can be thought of as a percent. It gives you an idea of how many data points fall on the regression line. More specifically, R squared gives you the percentage variation in Y explained by X variables. For example, R squared equals 0.51 between height and weight. It means that 51% of the variation in weight can be explained by the variation in height.